Okay, this is another question from another past paper. This is past paper November 19, question paper 4, variant 2, page 14, question number 5. The same idea, he gives you part of an instruction set for a processor, and we have the opcode, the operand, and the explanation. So let's move directly to the question. A programmer needs a program that multiply a binary number by 4. So how do we do this using the low-level programming language? He gives you some hints in the command here. He's saying that load content of number. This is of course direct addressing. So we have to use the command from the table given, which is LDD and number. Okay. Now we move to perform shift to multiply by 4. Okay, so let's explain this one first before we answer the question. Suppose that we have 1 in decimal, which is equivalent to 1 0 0 0 0 0 0 0 in binary. This is 1 in decimal. And to multiply 1 by 4, if we multiply 1 by 4, it means 4 in decimal. And this is how we converted 0, 0, 1, 0, 0, 0, 0, 0. Because this is the weight of in decimal for the first bit. This is 2, this is 4, 8, 16, and so on. If you multiply 4 by 4 again, because he's saying we have to multiply by 4, it gives you 16, and this would be 16, 0, 0, 0, 0, 1, 0, 0, 0. As you can notice here, from each of the examples, we are shifting each bit by 2 positions to the left. So 1 here got shifted 1, 2 places, okay, to become 1 in the third place. Here, 4 is going to be shifted also 1, 2 to become 16. Okay, so all the time we're going to shift by 2 to the left. And he gives you the command of shifting to the left in the table. Let's have a look at this one. So where that command here, this one is shifting the binary values in the accumulator to the left, and this is the number which should equal to 2 in our example. So let's move on and write this one down here. The form shift, which is LSL, as we saw in the table, and the value, and it should be immediate value of 2, as we explained. So the shift here is 2. Store the content of accumulator into the number STO. This is the command of storing, and it's in the table into number. Okay, type and end the program, and this is also given to you in the table. And okay, let's move on to the next question. Here he's saying that the programmer wants to write a program which counts the number of lowercase letters in a string. So he gives you some of the hints here in the comment. Initialize the index register to 0. This is the command given to you in the table, which is how to load the value to the index. And load the next one, load the next value from the string. The next value from the string. That means you're going to depend on the value of the index. This is the relative addressing. So we have to count the addresses starting from that address of the string and the value in the register. Okay, so here we're gonna say LDX let's have a look at the table to know what does it mean. Okay, LDX. So LDX and an address means indexed addressing. So we have that address given to us in the question, and we're going to add to this one the value or the content of the index register. Okay, so let's move on. So this one is going to be LDX and string. Okay, which means actually add the value of the index to that address. Okay, to go to the new address where the value is stored. Okay, perform bitwise AND. So we are gonna perform bitwise AND. That means we're gonna take that value from the accumulator and use the logical operator and with the mask address. So how do we do this? Let's see how do we do the bit AND from the table given here. Okay, and this is how we use it, because he gives us an address called mask. So we're going to use this one, not the one above, which is an. So let's move on and solve this kind of question. Okay, here perform the bitwise AND. So we're going to say AND and the mask. Okay, variable or address. Then check if the result is equal to mask. So we're going to use compare CMP with mask. If false, so JPN from the table, jump to upper. We just read upper, the label upper. Then increment count here. This one had we can break it down into three statements, three opcodes. So first of all, we load the count value into the accumulator. So we're gonna say LDD count. Then we're gonna increment count. We're gonna increment the value of the accumulator by using that command from the table inc count inc acc. Then we're gonna store back the updated value to the count. So we're gonna say sto count. Okay. So this is the idea. If you want to update a value of one of the addresses, you have to load that value from that address into the accumulator, then add or update or load or add to this value something, then update again the original address with the new value by using STO. Here he's saying increment index, gonna increment by adding 1. Then after increment, he's saying decrement the length. The same idea of count, the same example here. So we're gonna say L D D length. Okay, length. Then I'm gonna increment decrement. He's saying decrement. So DEC from the table. Decrement ACC, because we loaded already the length into the accumulator. Then we're gonna update, which is STO, means store the value from the accumulator to the length, which actually means update the value of length. Then he's saying that is length is equal to 0. Of course, now the value of the accumulator contain the value of length, so we can just say compare CMP with direct oh sorry, where is immediate value 0? Because the value of the length is equal to the value of the accumulator. So we compare the value of accumulator with the 0. If false, that means J, P, N. If it's false, again, we jump to the start. Okay. And then end the program. Okay. That's it. This is how we solve this kind of question. I hope that you understood it.